Fine. So I will clean up these things first, and let's talk about the data types that we have there. Fine. Okay. Now we have the data type like byte, short, int, long. All of them can store uh, integer type of data. Fine. You can see byte x is storing integer type of data. If I try to write this decimal data to this, like say 10.5, it cannot store that 10.5 because that is a decimal. I cannot store in a byte any string value. It gives me an error there. So whenever we are taking variables, variable means a memory location. What is a variable? A variable is the name given to memory. Fine. Let's say the variable of type. See, it depends on the type of data that we want, the kind of data we want to store. Based on that, we have to decide the data type of a variable. For example, let's say I want to store a phone number. That's called as mobile number is what I want to store. So what do you think for a mobile number? What should I take the data type as? Out of these data types which I have shared you, what data type should I take?
Long.
Long. Okay. How many of you suggest long? Raise hand. How many of you suggest long type of data type should be used for mobile number? Okay. So why long needs to be taken as a data type for a mobile number? We can take integer also. Okay. Why a long? Why a long?
Memory storage is.
Yes. See this byte, short, int, and long. All of them can store what?
Integers.
Pure integers. Phone number is a pure integer, right? It doesn't contain any decimal, right?
Yeah.
Okay. So let's take a byte mobile number. And let's say our mobile number is 9988777755. So when I take this, is it storing that number into this byte type of variable?
No.
No.
No, sir.
Similarly, what I will do is same mobile number. I will change the type here. I will take short. Is it storing that?
No.
It still
No,
gives me an
sir.
error. The type mismatch. No, cannot be stored in short. Let's take int as well with this. Is it storing it integer?
No, sir.
No. And let's say long. Is it storing in long? Not even in long.
No, sir.
The reason is when I have a long number, I have to write it as L. When I have a long number, I have to write it as L. Then you might be thinking like for integer, it should be I. Nothing like that. Nothing like that. For short, it is yes. Yeah, it is. But this can be stored, right? For byte, this is valid. For int, this number is valid. Correct, no? Let's say 1, 2. Different names of variables should be taken. 3 and 4. All are valid?
Yeah.
All are valid?
Yes.
So for mobile number, what we have to take?
Long, sir.
Long. Now, why should we take long only? Why not int? Why not short? Why not byte? All of them store integer only. Why not this? Fine. So let us understand that. So first I will write all that as it is. Fine. Why should we take mobile number as long? See, let's say age there is a age variable. We will understand with this variable. The same concept, why to take long with an integer, we'll same understand that with age. Okay, so with age, what type of variable should I take? Tell me. If it is pure integer, I don't want to tell the age is like 16.1, 16.2. I'll either tell it as 16 or 17. So what type first?
Short int.
Integer, right? Pure integer. So in pure integer, I can take byte, short, int, or long. So what do you think? What should I take here?
Short.
Byte or short? Somebody is saying short, somebody is saying byte, some might say int, some might say long. Fine. Okay, let's say a byte. Age equal to, what can be the maximum age of a user?
200. 100.
Can 100 fit in into it?
Yeah.
100 can be stored in byte, right?
Yes, sir.
Okay. So let's say 110 is the maximum one. Some exceptional case. Is it still valid?
Yes.
Okay. Same value can be stored in short as well. Same value can be stored in short or not?
Yes, sir.
Yes. But why should we take it as a byte? So let us understand that. And how do they differ? Why we have 4 different data types for same type of data? This data is pure integer, no?
Yes, sir.
This data is also pure integer. So why should we need 4 different types when it is same type of data? How do they differ? What is the difference in them? The similarity is all of them store
Integer value.
integer values. Let us see what is the difference in it. The difference is in its size. In what thing they differ? They differ in size. Means the capacity, how much amount of data they can store. So this is 1 byte, which is 8 bits. 8 bits of memory it can store. A variable is a, what is a variable?
Name given to memory.
Name given to a memory, right? So it's a memory location. End of the day, it's a memory location. So this byte memory, if you declare, it is going to take 8 bits. This is going to take 16 bits. Int will take 32 bits and long will take 64 bits. Now, if suppose to store age, if I take long, how much memory I'm utilizing?
64 bits.
64 bits. But maximum age can be how much?
3 bits.
Let's say 100. Let's say 100. 100 can be stored in 8 bits. Can 100 be stored in 8 bits?
Yeah.
Yes.
Yes,
If
sir.
100 can be stored in 8 bits, why to take 64 bits? When 100 can be stored in 8 bits, why to take 64 bit? Is it not a waste of memory? For example, if you can get full by purchasing a burger of 100 rupees, will you purchase a burger of 500 rupees? Same burger, just the size differs, taste is same. Will you purchase?
No.
Why?
We're getting 100 rupees.
Yeah, it will be waste, right?
Yes, sir.
It will be waste. So here in programming, memory is like money on it. We have to be very precise about saving the memory. Now let us understand, how does this differ? Like what memory I'm talking about, how this 100 can be stored, or why are we talking about this bits and all that? Let's understand that. Okay, so when I say memory, tell me, what does the machine understands? Your computer can understand and what type of language?
Binary.
Binary.
Zeros and ones.
binary, which is
Zero.
either 0 or
0.
so your computer is not intelligent enough to understand 2. Can it understand 2?
No.
No, it only understands either 0 or
One.
1. Each memory block can store either 0 or 1. How many memory blocks I have created here?
8.
Eight.
8. So let us call this as 8 bits of memory.
Yes, sir.
8 bits of memory. So 8 bit equals to how many bytes?
One.
1 byte. Super. So a minimum memory that we can reserve is 1 byte, right? We have to at least reserve 1 byte of memory. Okay. So this is byte, and this byte can either store 0 or it can store 1. Nice. So let us store all ones here. Everything is 1. Acha, wait a minute. Before that, before I enter 1 and everything into it, my machine can understand only what?
1 and 0.
1 and 0, right? Can my machine understand A? Can it understand A?
No.
No, it cannot. How will we make, but we are writing A in our machine, right? We write A, B, C, D, E, F, all that, 2, 3, 4, 5, 6, all that. Such things we write in our machine. How do they understand that A is written? Acha, based on his ASCII value. So what is the ASCII value of A? Capital A?
65. 65.
65. Can my machine understand 65?
No.
No, it can understand only 0 or
1.
1. How will we make it understand A? So you are saying make it understand 65. If we can make it understand 65, it will consider it as A, no problem. But how will we make it understand that it is 65, right? So what we have to do is, I hope in your binary number system, you have learned this algorithm. These indexes are given numbers, right? All these memory blocks are given numbers like this: 7, 6, 5, 4, 3, 2, 1, and 0. Have you studied about this binary number system in your colleges? Super. Acha, what is the formula to calculate this? 2 raised to the index position, right?
Yes, sir.
Okay. So let's say 2 raised to index position equals to the number, right? Yeah. So this is the formula, 2 raised to index position. So this logic, I guess you already know. Let's start it from here. 2 raised to 7 is how much?
128.
2 raised to 6 is how much?
64.
64.
2 raised to 5?
32.
32.
4?
16.
Then
Eight.
3?
8420.
2, 1.
2 raised to 0? Anything raised to 0 is
1.
1.
1. Okay, not 0. Anything raised to 0 is 1. All right, super. So this is how we calculate the stuff. And if 0 is written, we don't calculate the number. Okay.
Yes, sir.
And if 1 is written, we calculate the number above. How do I write 65 in binary? What is the binary equivalent for 9 or 7?
0 1
1.
1 1 0 triple.
Right? Triple one.
Yes.
You can say it as triple one or 0 triple one or 0 0 0 0 triple one. All
Yes.
that is fine.
Yes.
Fine. So wherever is 1, we are calculating that, right? 4 plus 2 plus 1. That is 7, correct?
Yes, sir.
Okay. Let's say, what is binary number for 9? 1 here.
1 0
here.
0 1.
It's 1001, right?
Yes, sir.
8 plus 1, 9. Super. So what is 15? 8 plus 4 plus 2
One,
plus 1.
1.
Is this 15?
Yes.
Everyone, are you getting this point? Wherever
Yes.
1 is written, we are going to add that.
Yes.
All right. So tell me, like, when I write one here and one here, how much it is total? Rest all is 0. I'm not writing 0.
65.
65. Okay, nice. So this will sum up to 65. 65 means what?
1.
65 means what in ASCII?
A. Capital A.
So did we make our machine understand A?
Yes.
Yeah.
Yes. Can we make our machine understand 2?
Yes, sir.
Yes.
How?
1.
1.
1
1
0.
0.
1 0.
1 0.
Right. So if 0 is after it, we write that 0. And if it is before it, we don't write it. So if we want to make our machine understand 2, we have to write 10. Not 10, 1 and 0. Fine.
Yes, sir.
Super. So if everything is 1 here, then how much is this total?
253.
255. 255.
255, right?
255. Yes, sir.
Yeah. So there is one more magic in the numbers that are following over here. You can see each number there, fine, is a sum of all the preceding numbers minus 1 or plus 1, right? You look at 8. Is 8 addition of all its preceding number, that is 4, 2 plus 1, 4
Yes.
to 1 and plus 1. 4 to 1 is 7 plus 1 is 8, right?
Yes.
You look at 16. 8, 4 to 1 is 15 plus 1 is 16.
Yeah. Yeah.
You look at 64. 32 plus 16 plus 8, 4 to 1 is
63.
65 plus 1 is 63 plus 1 is 64. You look at that 128. You add all the remaining one, it will become 127. Plus 1 is
128.
128. So you add all this 128 plus 64 plus 32 plus 16, 8, 4 to 1. That is 128 plus 127. How much? 128 plus 127 is how much? 255. The next number will come into the memory is 255. And this, if we sum up, is going to be how much? 255. If we calculate all of this, this will be 128. See, it's like this. Both the numbers plus 1 is 4, right? Both the numbers plus 1 is 4, right?
Yes, sir.
Yeah, all three numbers plus 1 is 8.
8.
Yes, sir.
Okay. All this 4 number minus 1 is how much? All this 4 number plus 1 is how much?
32.
16.
All these numbers, all these
32.
numbers.
30.
32.
16, 8, 4, 2, 1 plus 1 is 32, right?
32.
Okay. 32 minus 1 is how much?
31.
Is it
31.
a sum of all of this?
Yes, sir.
Yes. 64 minus 1 is how much?
63.
63.
Is it the sum of all of this?
Yes, sir.
Yes, sir.
128 minus 1 is how much?
127.
127.
Is it the sum of all of this?
Yes, sir.
Yes, it's a sum of all of this. So that's why this total we can do it just like 128 plus 127. We'll get the result as 255.
55.
Okay.
Yes.
All right, super. So this number game you are understanding. Very good. Now we have two things. Fine. What is that? A signed integer and an unsigned integer. Heard about it? Like minus 10 and 10. Heard about this?
Yes, sir.
A value that comes up with a sign, a value that comes up without any sign, right? So value should be given with the sign so that we can get the appropriate value, correct? If no sign is given, then it is considered as what? Positive number. We never write it as plus 10. Do we?
No.
No needs.
So if all are 1, 255. But can we understand whether it is plus 255 or minus 255?
By using simplified bit, we can
No, right? Let's say only 7. 7 is stored in the memory. How do you store 7 in the memory?
Triple
Like
one.
this.
Triple one.
But is it plus 7 or minus 7?
Plus 7.
plus 7.
Plus 7, right? If I want to store minus 7, then what?
By using sign bit. Yes.
Right? So what happens is there should be some sign. So what happens in the memory is not all the memory in a byte is occupied for this. Let's say all are 1 means how much the total should be?
259.
255. That means byte should be capable of storing 255. Okay. Maximum in byte should be how much?
255.
If I store 255, is it storing that?
No.
Is it storing 255? No, it is not
No.
storing 255, which means that the maximum which we calculated, something is wrong here, right? Okay. Let's say, what will be the sum total of all of this?
127.
127. So let us try 127 into this. Can I store 127?
Yes, it's possible. Sir.
Yes, 127 can be stored. Okay, let's say 255, which is not valid, which is going to give us an error. I'll put this in comment so that you can later expose these things. You will understand, okay, he tried this, and later he came to this solution. That's what you can think. Acha, 127 can be stored, which means all of this. Let's say 128. Can 128 be stored here?
No,
No,
sir.
sir.
128 cannot be stored. That means the maximum number which can be stored into byte is how much?
127.
127.
127, which means only the 7 blocks are used or 8 blocks are used. Maximum is 1, minimum is 0, right? That's what we can store in memory. Yes or no?
Yes.
So if all of this are 1, what is the sum total?
127.
127.
So it means that I can only use this. I cannot use this. Can I use that?
7 blocks.
If I was able to use it, what should be the maximum number?
255.
55.
255. But am I able to use that or not? What does my program say? 255 can be stored or not?
Not.
No, sir.
Only 127 can be stored. Even 128 cannot be stored. 128 is not possible. Nice. So let us understand why is it not possible. Why only 127? Why only these blocks are used? This last block is reserved for what?
Sign.
Sign.
Time. Where 0 means
Positive.
positive, 1 means negative. Okay.
Yes, sir.
Last bit. If it is short, then how many blocks of memory we will have? This is the byte diagram I am drawing. Byte has how many blocks? How many bits?
8
8
bits.
bits.
8 bits. If it is short, how many bits?
16 bits.
16 bits.
Bits. In short, at which position we will have the sign?
7.
7 position.
In short, I am saying
16.
16.
16. We will
15,
not
15,
have
sir.
15.
15.
1 5.
10.
Fine. 1 5. 15. 16th position we will not have because indexing begins with what?
0.
0.
0. Okay. Nice. So if all of this are 1, what is the maximum number stored?
127.
127.
127. Consider all of them as 0. All of them, even including this, everything is 0.
Yes.
What is the result? Including the sign.
0.
0, right?
No.
So 0 can be stored or not is what we will test. 0 can be stored. Okay.
Yes, sir.
It is compiling fine. If I do a system.out.println x, it will give me that x can store 0. Compilation itself tells me whether it can be stored or not. Is it giving me 0?
Yes.
Now let's check whether I can store minus values or not. Can I store minus 10 here?
Yes, sir.
Yes, sir.
Yes, minus 10 can be stored. Now, how is minus 10 stored in the memory is the question, right? How do you
Yes,
store
sir.
minus 10 in the memory is the question, correct?
Yes, sir.
Okay. Now let me draw this once again. Same stuff over here, and we will think of minus positive. I guess it is clear to you.
Yes, sir.
Okay. So let us remove this 111.
తీసుకో
Let's remove all of that. First thing is, tell me what are we trying to store in the memory?
minus 10.
ఇది
Minus 10 is what we are storing there. Okay.
నా సెల్ మామూలుగానే వాడుతుంటది కదా
Acha. So minus 10, which block is reserved for the sign?
7.
Last one, right? What means negative? What means positive?
One means negative,
Zero
0
means
means
2 means positive, 1 means negative.
Okay, so negative number, we are storing negative or positive?
negative.
So it should be 1 here.
Yes, sir.
Yes, sir.
The moment it is 1, what is calculated? 128
Negative.
is calculated or not?
Negative numbers.
128 is calculated or not?
Yes.
See, wherever we have 1, we calculate it or not?
Calculate it.
Above case, if there is 3 where 111, we calculate 4 to 1, right?
Yes, sir. Yes.
Okay. So here 1 is at what position? 128. So we should
Yes.
calculate 128 or not? Yes, we should calculate. But since it is at the last position, what should we calculate this as?
Minus 120.
You have to calculate it as minus 128. Okay.
Yeah.
If it is only minus value and rest all are 0, what is the value stored in the byte?
Mine.
If it is 1 and rest all are 0, what is the value stored there?
Minus 128.
Yes. So first we will check whether it is possible to store minus 128 or not. Can I store 128 plus 128? Is it possible?
No, sir.
No.
Not possible to store plus 128 because the memory does not fit in for 128. We don't have the memory for 128. Now when I add this 1 here and rest all are 0, it is minus 128. So we have memory for minus 128. Can it be stored here?
Yes, sir, it's possible.
Yes, we can store minus 128. You can save that. You can see that. Is minus 128 is stored in byte? Stored, right?
Yes.
So
yes
now minus 128, and here also if it is 1, here also it is 1. So what it will be? What it will be?
64.
Minus 128 plus 64 is how much?
minus 64
So this will be equal to minus 64, right? Nice. So minus 128 plus 64 plus 32 is how much? Minus
Minus
128
32.
plus 64 plus 32. How much?
Minus 32.
Minus 32.
32 minus
This will be minus 32.
32.
32.
Okay. Minus 128 plus 64 plus 32 plus 16 is how much?
Minus 16.
Minus 16.
Minus
Minus 16. Okay. Minus 128 plus 36. Oh, sorry. 64.
64.
Here also I have written 36. 64 it should. 64 plus 32 plus 16. Up to here, how much it was?
minus 8.
Minus 50.
Minus?
Minus
8.
16.
Minus
Minus
16.
16.
Sure?
Yes,
Yes.
sir.
64 plus 32 plus 16 is how much?
112.
64 plus 32 plus 16 is how much?
112.
112.
112.
112.
112.
112.
Okay. 128 minus 112 is how much?
16.
16.
Minus
Minus
16.
16.
Minus 16.
Minus
Okay.
16.
Okay. Now minus 4, sorry,
Okay.
plus 4 plus 2 is how much?
Minus 10.
Minus 10.
Minus 10.
10.
Minus 10.
So if you want to store minus 10 in memory, what should be the result here? 1, 1,
0,
1, 1,
0, 1, 1.
1, and 1 here. Correct? This will be the memory
Yes.
for minus 10. Have you calculated minus 10 anytime
Yes,
in
sir.
binary numbers? You usually calculate the plus numbers, right?
Yes,
You
sir.
usually
Yes.
convert the
Yes,
plus
sir.
1 into the binary or binary into the positive number. If you want a minus 10, this will be the binary number. For fine with this? Is this fine?
Yes, sir.
Yes.
Yes,
How you
sir.
write that? Super. So now, next point, which the actual point is clear here itself. So if I want to store anything into a variable, I am taking memory for it. Based on the value of that, I have to decide what is going to be the type of the variable. No? Like here, if I want to store age, I have to decide what is going to be the maximum value in that. If the maximum age I am taking as 100 or 110 or 120, I would rather take byte. I will not take short, int or long, right? Why do I need short, int and long when I can store it into byte? What's the maximum number that can be stored into byte?
127.
127. Fine. So if you are storing days of 3 months, what type of variable you will take?
Byte.
Byte, because it is 90, right? It
Yes.
can be 90 or it can be 93. Worst case scenario, it can be 93, right? 3
Yes,
months. Will not take integer for it. Age will take byte, will not take integer for it. So based on the value that will be given to a variable, you will decide the type of the variable. So phone number begins with what? Mobile phone number begins with what?
Long.
Begins with 9 and it has 10 digits in it, right?
Yes, sir.
That will not fit into integer. That's why we have to take it as long.
Long.
Got to know the reason why we have to take long? Why not integer? So you try this in integer. If it is integer, mobile number equals to, if I write like 4, 44, 77, 88, 99, 55. How many? 2, 4, 6, 8, 10, right?
Up to 2000 only.
Yeah. So if I write 1, 4, 77, 88, 99, 55, is it fine? Is it
Yes,
fine?
sir.
Is it giving me any error? No problem. No errors. The moment I take it with 2, begins with 2 problem, because it goes beyond its capacity. So you can see, put a cursor on it and you can see the literal, this number is out of integers range. Does that error tell me that it is out of its range? Range has gone beyond integer, right?
Yes.
So phone numbers don't start with 1. It can store 10-digit number, but not starting with 9. Can it store a 10-digit number starting with 9? Integer?
No, sir.
Goes beyond its capacity. So based on what you are storing, you have to take the variable. Is that clear? Why we have 4 type of integer type of data? Why do we have 4 variables? Why not just 1? Acha, can long store everything?
Yes.
Yes. So why not take long all the time?
Because it
Memory
consumes
space.
more memory.
More memory.
we don't want to waste the memory.
Save
That's why
memory.
we take other type of variables. That's why there are 4 different variables type is given to you when it comes to storing integer type of data. Okay, is that clear?
Yes, sir, it's clear.
Yes, sir.
Okay, and next